Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this my YouTube channel. Today we will be discussing the different types of instrumental methods in the pharmaceutical analysis. Already in previous lectures we have covered with the analytical separation techniques. In this video we will be discussing the analytical spectroscopy, which are based upon the electromagnetic radiation. Now if you have not watched my previous lectures, then you can watch my previous videos also related to the pharmaceutical analysis. If you like the content of this channel, then you can subscribe to my YouTube channel, share with your friends. So let's begin with our today's session, that is analytical spectroscopy. Before that, we will see what are the learning outcomes of this session. Means after watching this lecture, you will be able to explain the different types of instrumental methods. Means these are the analytical methods which are based upon the use of different instruments. Because of use of different instruments, the accuracy and precision of these analytical methods is more. Now, as I said, in this video we will be discussing about the analytical spectroscopy. Now, what is the meaning of spectroscopy? These analytical methods which are using electromagnetic radiation or the light energy for qualitative as well as quantitative determination of compound are known as the spectroscopic method. So all these analytical spectroscopy methods involves the use of electromagnetic radiation. Now what is the meaning of electromagnetic radiation? You have heard about the ultraviolet rays, then visible rays, infrared, that is the IR rays. So all these radiations are nothing but the electromagnetic radiation, and the different interactions of the different matters with these electromagnetic radiations is nothing but the use of the spectroscopy. They are broadly divided into two types, namely absorption spectroscopy and the emission spectroscopy. Absorption spectroscopy means what? Whatever the molecules or the atoms that are present in the sample, they absorb the radiations from the different source. And in emission spectroscopy, the molecules from ground state will go to the excited state where they are unstable, and while coming to the ground state, again they will emit the certain amount of light. So basically there are two types of spectroscopies. One is the absorption, other one is the emission. In absorption spectroscopy, the light energy is absorbed by the sample, whereas in emission spectroscopy, the light energy is first absorbed and immediately it is emitted by the sample. And this amount of absorbed light or the emitted light is measured, or this is the basis for this all analytical spectroscopy. Now, first spectroscopy that we are going to see is ultraviolet visible spectroscopy. Now, this is the most important or simple technique for this spectroscopy, which is widely used for determination of the quantitative analysis. Now, what is the meaning of UV visible spectroscopy? Now, there are two different types of radiations. One is the ultraviolet radiation and other one is the visible radiation. Now, our human eye can see different colors like red, green, blue, indigo. Okay. So why we are able to differentiate between these colors? Because that the wavelength that are emitted or the rays that are emitted from these objects are having different wavelengths, different energy, and depending upon that change in energy, we are able to see these radiations. So human eye can only see the radiations that are present in the visible region. Rest of the regions, ultraviolet radiation, infrared radiation, microwave radiation, these types of radiations we are not able to see. Now, ultraviolet visible spectroscopy is a type of absorption spectroscopy in which light of UV visible region, means those are ultraviolet radiations as well as the visible radiations are absorbed by the molecule. Now these ultraviolet radiations or visible radiations, the range of these radiations is 200 to 750 or 800 nanometer. Absorption of radiation leads to excitation of the electrons from the ground state to higher state, and the energy of ultraviolet radiation can be calculated as it is equal to energy difference between the ground state and higher energy state. So all molecular spectroscopy are based upon this principle that after absorption of radiation, electrons that are present in the ground state, they will go to the higher state, and at higher state they are not stable and they will come to the ground state, and while coming to the ground state they will eliminate the certain amount of energy. Basically UV visible spectroscopy is based upon the Beard-Lambert law, which says when a beam of monochromatic light is passed through a solution of an absorbing substance, the rate of decrease of intensity of radiation is directly proportional to the thickness of the absorbing solution as well as the concentration of the solution. So this is about the ultraviolet spectroscopy. Then next type of spectroscopy, that is the atomic absorption spectroscopy. This is the analytical technique that measures the concentration of the elements. Again, it is used for the quantitative analysis. Atomic absorption spectroscopy is used for measuring the quantities of chemical elements present in the environmental samples by measuring the absorbed radiation and the chemical element of interest. This is done by reading the spectra that is produced when a sample is excited by the radiation. Here also we are going to use the ultraviolet as well as the visible radiation for the atomic absorption spectroscopy. The atoms which absorb either ultraviolet or visible light and make transition to higher energy levels, and after making transition to the higher energy levels, the amount of light that is absorbed by that particular sample is measured by using the atomic absorption spectroscopy. Now atomic absorption methods measures the amount of energy in the form of the photons of the light that is absorbed by the sample. Then next, one of the important spectroscopy that is used for the determination of quantitative determination of the structure of any sample is infrared spectroscopy. This is also one of the important spectroscopy. By using infrared spectroscopy, we can identify which type of functional groups that are present in our sample. Means whether acidic functional group is there, ketone functional group is there, alkane functional group is there, alkene functional groups are there. So all these types of functional groups are measured or identified by using infrared spectroscopy, which utilizes IR radiations. That is the infrared radiation. Infrared spectroscopy is also absorption spectroscopy, in which infrared radiations are utilized which are present next to the UV visible radiation, and this is the very broad spectrum is there, which is having about 700 nanometer to 1 millimeter wavelength. So this is the very broad section. These infrared radiations are also divided into 3 different sections, that is the near infrared, far infrared and middle infrared spectroscopy. Infrared spectroscopy is a technique which is based on the vibrations of the atom of a molecule. There are 3 different types of energy that are possessed by the molecule, that is the vibrational energy, rotational energy and electronic energy. So these infrared radiations will cause changes in the vibrational energy of that particular molecule. So it is based upon the vibration of the atoms that are present in the molecule. An infrared spectrum is commonly obtained by passing infrared radiation through a sample and determining what fraction of the incident radiation is absorbed at a particular energy. The energy at which any peak in an absorption spectrum appears correspond to the frequency of the vibration of a part of the sample molecule. In infrared spectroscopy, it provides mostly information about the presence or absence of certain functional groups. As I said, it is used for determination of the presence of different functional groups. So along with the ultraviolet spectroscopy, infrared spectroscopy, these tools can be used for determination of the structure of an unknown compound. Means if we are having any sample in the powder or liquid form, we can determine if it is in pure form, we can determine the structure of that particular compound in that particular sample. For that purpose, this infrared spectroscopy is one of the important technique. Then next important technique that is also useful for the structural determination of unknown pure compound is mass spectroscopy. In mass spectroscopy, we are going to measure the mass to charge ratio values and their relative abundances of ions. Basically, just you can remember that this technique is used for a determination of molecular weight. We know, for example, benzene. Benzene is having molecular weight of 78. So with the help of this technique, we can determine the molecular weight of that particular sample. So that will give us a broad idea about the elements that are present in our sample. In mass spectroscopy, bombardment of sample with electrons is carried out and the detection of resulting molecular fragment will take place. It provides information about the molecular mass as well as the atom connectivity. Then next important technique that is used in the spectroscopy is Raman spectroscopy or Raman spectroscopy. In Raman spectroscopy, this is also based upon the vibrational motion of atoms that are involved in the molecule, like infrared spectroscopy. But this infrared spectroscopy and Raman spectroscopy, these are the two different physical methods. This Raman spectroscopy is based upon the observing the vibration, however different from the infrared spectroscopy. In Raman spectroscopy, one measures the light scattering, while the infrared spectroscopy is based upon the absorption of photons. Scattering means what? Suppose different solid particles are present in their solution, and if we pass the light from that sample, whatever the light that is falling on the surface of that solid particles, it will not transmit. It will be deflected, and this is nothing but the scattering effect. So Raman spectroscopy is based upon the measuring the scattering effect, while infrared spectroscopy is based upon the absorption of photons. In Raman spectroscopy, sample is illuminated with the monochromatic laser beam, which interacts with the molecules of a sample and originates a scattered light. Then next technique that we are going to discuss is a nuclear magnetic resonance spectroscopy. This is also one of the important technique along with the ultraviolet radiation spectroscopy, then IR spectroscopy, mass spectroscopy and NMR spectroscopy. All these four techniques are useful for determination of structure of that particular molecule. In NMR spectroscopy, it is based upon the absorption of radio frequency waves. Here, radio frequency waves are generally utilized by atomic nuclei with a sample that is placed in the magnetic field. In NMR spectroscopy, excitation of nucleus of atom takes place through the radio frequency irradiation. It provides extensive information about the molecular structure as well as the atom connectivity. In detail, we are going to discuss all these techniques, but just for the introductory part, we are going to discuss in short what are the different these techniques. The next technique is polarimetry. Polarimetry is a sensitive, non-destructive technique for measuring the optical activity exhibited by inorganic as well as the organic compounds. A compound is considered to be optically active if linearly polarized light is rotated clockwise or counterclockwise when passing through it. The amount of optical rotation is determined by molecular structure and the concentration of chiral molecules in the substance. So here we have discussed these various analytical spectroscopy techniques. Still few analytical spectroscopy techniques as well as the miscellaneous methods are remaining. We will see these methods in the next video. Thank you. If you like the content of my channel, please like my videos.